That way it will be evaluated. So after showing your result of the previous week, say from today to next Wednesday, 3 or 4 experiments you need to complete. Maybe at the beginning it will be little bit slow, 2 to 3 experiments you can complete. So once you show the result, maybe you can log out and start working the next set of experiments. There is no need for you to log in for 3 hours. Do you think it is needed? Because list of experiments is given to you. Hmm? Is it okay?
Okay, ma'am.
So something what you have to do is of experiment somewhere in here. Varun, can you read out the first set of experiments dictated?
Okay, ma'am. Like flow things, ma'am, using data flow ones.
Hmm.
Section 1 was using data flow ones, ma'am.
Using data flow, what were the experiments?
Development of Verilog models in data flow style, 2 to 4 decoder and 4 to 16 decoder. This is first experiment, and second is 8 to 3 encoder.
Then
Then
third one.
4x1 and 8x1 multiplexers.
So, okay, these things will be simple in data flow. Okay, at a single shot you can complete. That means 1 week time. 1 week time you can complete. You, if you have doubts regarding how to write and all, you can take the help of the theory, the DSD one theory, whatever we had. There the explanations are there. Still, if you have doubt, you can contact me. Okay. So,
Okay.
what are the different styles of modeling and all? How do you write? I think in the previous lab it was introduced. So, at least did you start reading that? Did you start?
Yes, ma'am.
Yes, ma'am.
Yeah.
Like
So, okay. So, your structural style of modeling needs the component information. Your data flow needs your what you say, the Boolean equation format, and your behavior style of modeling needs the truth table information of that design. Okay. So first set you are saying data flow. So simple equations of the outputs, if you can derive and write it in a code form, that completes. It will be 2-3 sentence statements only. How many number of outputs you have, that many equations you will be writing, as simple as that. Max if you take one equation, okay. Say if you are taking decoder means it needs how many? Decoder. I think Aruna didn't join.
Sixteen.
Hmm. Size of decoder depends on the size of decoder. Na? What is the size given there?
For 2 to 4, we'll have 4 outputs. 2 to 4 and 4 to 16.
So depending on the size, you need to derive the equations. Can you derive that in one single equation? No, na. Your decoder The concept of decoder. Can you tell the concept of decoder?
Delivering the data.
So it will be having the selection lines and the input line. Na?
Yes, ma'am.
So depending on how many selection lines you have, that many number of 2 power, the number of selection lines will be the outputs. So try to draw the block diagram, all of you. Done?
Ma'am, for decoder, will there be input line?
What is the difference between demux and decoder?
Yes, ma'am. Demux will give location where to go and data also will be carried, no, ma'am.
Decoder gives you
Decoder,
the destination.
yes, ma'am. Decoder gives us only destination.
Yeah.
Then input line will not be there, no, ma'am.
If it is demux, input line, data line will be there. If not, it is a simple combination of your selection lines, which chooses the destination.
Okay.
Say 2 selection lines if you are taking, say S0, S1, S0 dash, S1 dash will be giving you first destination.
Yes, ma'am. Okay.
And 0, 1 combination, that way you'll be taking, no?
Yes, ma'am.
Because that is a simple experiment. Maybe let me. Screen is visible?
Yes, ma'am.
Yes, ma'am.
Hello, good afternoon, madam.
Good afternoon, Arna. 1 second. So if this is your S0, S1 selection line, 4 outputs. So you try to take the equations of this and this to be written in your code form. Say 4 set of equations you will be writing. Is this your data flow? Can I take this as data flow? That means how my inputs are carrying to output. That is data. Okay. Same thing, if you can put this into like internal statement sort of thing, that becomes behavior. So for behavior, if S0 and S1 is equal to a condition, then what will be your output will be D0, or D0 is equal, output is D0. Else, I think this for like as of now, today it is data flow, behavior. Don't get confused. I'll explain that in the theory session. Okay. So this will be your set of 2 to 4 decoder. If it is 8 to 3 encoder, 8 to 3 encoder. The concept of encoding.
Reverse
Priority
now. Like,
encoder we have seen now. There's something like 4 lines. If you have 2 output sort of thing was taken, and each priority line has its own priority levels. Either you can take this as top priority or this as top priority. It depends like how you are writing. So this is having less priority, and if no top priority, if this is top and this is less priority. If this is a requesting, then say you take this format. So if P1 is requesting, this becomes known K because this is low level priority signal 1. This is 1 0. This was your encoder. Remember this? Now you can play with this logic. It is saying
Yes,
8 is to 3. 8 is to 3 means that you need to have 8 priority lines, 3 outputs. This is 4 is to 2, no? 4 is to 2. You can do this with no request indication or with request indication. Both the ways you can do. This is your 4 is to 2. You implement that for 8 is to 2. That means you need to derive the equations of Z0, Z1. 2 simple equations. There, if 3 is to 1 means Z0, Z1, Z2 along with P0 to P7. Write the table, derive the equation, get the thing, okay? And mux anyhow, it is simple. Every time we are using that mux. So 2 is to 1 if we are having. This becomes your input and selection lines. So what are the inputs you are choosing? And what is your output? So this is your single equation element. So only writing the equations is needed for data flow. Okay, Aruna, are you ready? Aruna.
Ma'am, for the lab submission, do we need to write only the code and the all the outputs?
You need to write.
The very code and the outputs. That's all, ma'am. Or we need to dot tables and we need to submit them.
Yeah, let me tell before Aruna joins. I'll let you know. So for lab, your file needs to be having the format someone asked, no? Your report format or your folder format, both are same now. First page will be first page of your mini project. So this will be title, okay, along with your emblem, NIT emblem, okay. then roll numbers, then faculty name, and your department and year. That means this format will be the certificate format of this one. Title means mini project on. You need to write the title for the partial fulfillment of completing for the partial fulfillment of DSD 2 lab. And then you need to get the NIT envelope. Then follows your roll number. Say 4 students are there, 4 roll numbers. 2 faculty are there, 2 faculty names, department and the year of submission. Okay, this is the main paper. And next, second paper will be abstract. Sorry. This abstract needs what you say, summary sort of thing or brief description. Maybe it can be a small paragraph of 6 to 10 sentences. It depends on what is the complexity of your design. Okay, abstract. Then next comes your circuit or flow, whatever it is, circuit diagram or flow diagram sort of thing. Okay. Next is your theory related to your work. That means say A, B, C. You need to explain the circuit. You need to give all the complete details of your problem statement. Okay, theory. Maybe it is 2 we are saying next pages. This is first page, main page. You can take that way, main page and next pages. Okay. Theory. Then after theory, the code. And after the code, results. That means that this results will be your output file. Print out. This is final total report I'm saying. Okay. F will be your conclusion. Okay. Next, after conclusions, final will be your references from which you have taken the idea or the papers what you referred or whatever it is, the source papers, references. So this will be your mini project report. Any doubts are there here? See, this theory needs to address the complete explanation of your problem statement. So this takes at least 10 pages, maybe 8 need to write. It depends on the complexity. Any doubts? Is it clear?
Yes.
So next one, in your experiment folders. These folders, you need to write again the title, date of submission on the top, give the abstract. Abstract in the sense introduction sort of thing. Maybe this experiment introduction or something like a minute explanation sort of thing, if possible, or else direct action. Action means problem statement, the title. Say You're saying, say, 4:1 marks. You will be explaining that as what is that 4:1 marks, or what is the functionality, how to implement it, or the reduction sort of thing. In this thing, you'll be giving the circuit. Circuit diagram means now it can be a normal schematic also. Here it should explain all the pins, inputs and outputs details. Pins or inputs and outputs details should be there. Okay. Then give the truth table. Then for us give the equations. Whatever is possible. I'm listing out what to be given. Whatever is possible. Fewer times some designs you won't give the Boolean equations, or you may not be giving a truth table sort of thing. Direct circuit diagram or the schematic and the corresponding explanation, whatever is possible. I'm giving the options. Okay. For multiplexer or simple designs, you need to give the schematic, the truth table, and the Boolean equation. Complex designs maybe all cannot be possible. So circuit diagram, either of truth table or Boolean equation you give. So either you completely explain here itself, or else give the explanation as the theory itself. It's up to you. Both the ways we accept. Which one you need or which one you try to follow is left. Okay. Maybe give a title. Abstract is implementation of 4:1 multiplexer, which is a selection of the sources you can give. That means a summary sort of thing. Then you give the theory explanation. What is multiplexer? How you will be using that? How you are selecting? What will be your outputs? Okay, what is the specification? That means size. Say 4:1 means what, or something like that. What first number indicates, what second number indicates. All that theory explanation. Okay, then your code, you need to represent in the title the style of modeling. Style of modeling means we asked whether it is data flow. The same experiment you can write it in the structural style and behavior style also. So in title you specify the style of modeling. So implementation of 4:1 marks using data flow style. That should be title. For this, how do you write the title? Implementation of 4:1 marks using data flow style of modeling. This is your title. Okay, abstract is implementation of 4:1 marks for selecting 4 sources generating 1 output. That is your abstract. Abstract or say intro sort of. And give the clear explanation. And the code in that style of modeling. What is the style it is asked? Then your result. Result means you will be showing the output file. Print out of this. Okay. And your conclusion means normally every experiment we expect a conclusion. Say any deviation in the output or any deviation you're observing, you need to conclude what will be the reasons of your pitfalls or something like that. Or something like based on your results, you analyze. That is conclusion. It's not that I implemented Mux, I got the Mux. Not that is not the conclusion. Should be your conclusion. Normally, any experiment if you take, conclusion means you need to give one or two statements saying that your circuit was functioning efficiently. What is the efficiency or what is the speed? That way, normally any experiment we try to bring out the conclusion. Okay. Don't say that I implemented this experiment, I got the result. That is conclusion. No, don't do that. Okay. Is this clear? This is your folder. How you need to write the folder. Every experiment will be having this. That means this gives you the practice of learning the content first. The first segment, this gives you the practice of learning what is the what you say your total project in the sense the experiment, that related circuit diagram, the functionality, the background of that. That means this explanation gives you the background of the design. When you write this on your own, taking the help of any textbook or lecture thing, you will be learning much of the content, and this is the practical implementation. And if you write the code for yourself, you will be training yourself and you will be learning the Verilog or whatever type of codes you are writing there. Okay, and once you expertise in writing this, your mini project becomes very easy. Is this clear?
Yes.
Yeah. So Aruna has joined.
Good afternoon, madam. I joined, madam.
So I think who is presenting this?
Meghna, madam.
No. You'll present on your system or someone is presenting?
No, ma'am. Actually, I tried for that to present in my system, but for Meghna, she is having some technical problem. So she will share the screen. I will tell the steps.
Okay. So Meghna, you share your screen. I stop.
Yes, ma'am. Is it visible?
Yeah.
Yeah. I opened up the.
Okay, madam. Now,
Meghna, you mute your.
Okay, ma'am. Yes.
good afternoon, everyone. Madam, shall I start, madam?
Yeah, you start.
Okay, madam. So the Verilog coding can be done in Vivado this software or in Xilinx software. So now here we need to first create the folder to where we will write all the codes. So first we will create our project. So go to the file, okay, create project. And then continue next. So here the project name should be there. That is a user defined. Any project name can be given. And the project location you can see there the
We can't hear you.
Hello? Yes, ma'am. Hello?
Our system works.
Or in class, anyone having Xilinx software, they can share the screen so that I'll tell the flow. Shall I proceed?
Can you not see my screen?
Yes, ma'am. Now it is visible.
Okay.
Now you give project name as demo. So likewise, we'll give project name and go to next. So with this RTL project, we'll proceed. Then next. So here it is asking for add file. So now we go for the create file first. Here we will be giving the source files of Verilog code. So the file name is give some random name like half adder. So the file location is local to project only. Now press OK. So now next. Go to add files. Now the project you create, go to the demo. You can use up arrow is there, no? Right side. Yeah, press on that menu. And there demo folder is there, select it. So in that source file should be there. So here file of type. Here you select all files. So the half adder file is not visible there. Okay, you press OK. Then otherwise if not responding, can cancel it. Okay, now go to next. Next. Okay, now finish. Now we will add the source files to the project we created as demo. Okay, you press OK. Okay, Megha, you just cancel it. We will start with creating source file. So the window here like this is there. Now we'll create new source file here. So here under sources, one plus symbol is there, no? Please click on it. So here you press the third one, add or create simulation sources. Next. Go back. select the middle one, add or create design sources. Now you click on plus. Create file. So you give like adder. Click on the file location. Choose location. In that, go to the demo folder. Select it. Now press OK. So now the Verilog file named with the adder dot we created. So now finish. Okay. Okay. Yes. So under sources, you check once adder file is there. Otherwise here. Yeah, select double click on it. Now come to this here. Yeah, you drag down. So here if we see the module is created with the syntax like this module name, and the braces are there. After that, end module keyword also there. So every module followed by end module keyword. So here we will give the sensitivity list. So here we will define inside the brackets what are the inputs and what are the outputs. Suppose we are going to design half adder. So we will be having two inputs and two outputs, right? So the inputs are A comma B. You please type Meghna, A comma B. No. Inputs later we can define, just A comma B, comma S comma C out. So after the semicolon mark you come and press enter there. So now here we will define what are the inputs and what are the outputs. So input, type input space A comma B semicolon, and then output S comma C out. So after giving the sensitivity list, so here we defined what are the input signals and what are the output signals. Now we will write the we'll write the design code for the how to get the half adder. So we already know the expressions for the sum and carry for half adder, right? So you press enter and write like this, Meghna, XOR. So open brackets S comma A comma B semicolon. After that, and C out comma A comma B. So this is the code for the half adder. So now save it. So now in the leftmost corner we have simulation, right? Go to that simulation. Go to the simulation. Click on simulation. Okay, again run simulation. Yeah, run behavioral simulation. Okay, some error is coming. Did you ever simulated any code, Meghna, previously?
Yes, ma'am. I did one last night. Is that why?
Did you get the output?
Yeah, I did. There's an error here. I don't know what it is. Some
No,
syntax error.
you
To close the
close the curly brace before semicolon.
Here.
Yeah, close it once and resimulate.
It is down given.
What about this?
You remove that both semicolon and bracket. Remove that one.
Like this? Okay, I think this is should work. Okay,
Yeah, now save and run
I'll try
videos.
this. Okay.
So those who have not done or not explored till now, please note down the steps and follow carefully so that it will be easy for you. So here, after first it will check for the syntax error. If any syntax error, it will show notification like some error. After correcting syntax error, it will simulate and the simulation window will come like this. Here we will force the inputs. So go to email and right click on it.
Here?
Yeah. So here force constant is there. Go to force constant. So here select the binary value added, that is binary. So force value 1. Okay. Likewise, we'll force the value to B also. Give right click on B and force constant.
This is 0.
Yeah. So we force the required inputs. Now run the simulation to see the outputs.
Again, run here.
Here under reports, top corner. Under reports, one green, no, leftmost.
Here.
File edit flow, leftmost. File edit flow tools reports. Under reports, one green button is there. Under
Acha,
reports,
here.
yeah.
Okay. Run.
So
Which one?
yeah, run implementation. Okay, then run synthesis. Go to run synthesis. Cancel.
Okay. Run synthesis. Saying the same.
Okay, press OK.
Okay.
So here we have to get the outputs. For sum it is 1 and carry 0. So is there any other option is there?
Okay.
Press OK.
Okay.
Actually it is synthesizing the code. You come down the leftmost corner here. Okay, go up. In the run simulation, again we do.
It's doing something here. Don't know. Is that okay? Run simulation. Should I run simulation?
Yeah, once press it.
Okay.
Again, do run VLL simulation.
This finished. I open now.
So actually it is showing some RTL diagrams.
Should we just run simulation then?
Yeah. You do that one again. Run VLL simulation. Yeah, that one.
Okay.
Yeah. Okay, likewise previously you did force the inputs. So is there any run option available there?
There's a run up here. Oh, no.
Where actually some options are not visible to me. It is showing some highlighting like viewing your screen like that.
Ah, okay. There's a run on the top bar next to reports, window, layout, view, and then run.
Yeah, you click on the run. Actually, I am unable to see that option.
Okay. Run all.
Yeah, press run. So if you see here the outputs came after running. So the forced inputs are 1, 0. So the expected outputs for sum 1 and for carry it is 0. Likewise we can force, yeah. Likewise we can force different inputs and we can check the outputs. So everyone is clear with this, how to create the source file and how to run, and that's easy only. For Vivado Xilinx both are almost same, slightly differs for Vivado.
What does this mean, ma'am? The blue, red, and
Actually, that is showing some time units. Since we didn't give any time units, the outputs are evaluated at 0, the time equal to 0 itself.
okay.
So it is showing some likewise. If we write the code and force some graph, that means certain time period, it will show the outputs there.
Okay.
Suppose if you want like up counter, down counter, or any circuit which is clock based, there we will see the outputs.
Okay.
So anyone having doubt at any step, you parallelly you can try in your laptops. If you face any problem, you can share your screen so that we can discuss.
Ma'am, if I change this to 1 and 1, will this also change?
Yeah, it has to change. You change the inputs and this
Do I change it here?
yeah.
Like that?
Yeah, rerun like you did previously. So you can see, right, 1 1, the expected output for sum is 0 and carry is 1.
Yeah.
So all of you doing start doing parallelly with this issue. So everyone install either Xilinx or Vivado, IST tool or anyone is there till not install. You guys take the files or link from your friends and install them. You can try for the different codes. For example, if half adder is there, you can try in all the models like we discussed in the previous lab, like gate level modeling, data flow modeling, and behavioral modeling. In all these three modelings, you try uh, writing code for the half adder and simulating, so that it will be writing other programs will become easy for you.
Okay, ma'am. Can you share the PowerPoint that you used last class with all the modeling styles?
Yeah, I'll share.
Thank you.
I'll share to you and you share in your groups.
Okay, ma'am.
I'll share later. You have different circuits, right? You try practicing those circuits.
Okay. Is this all for?
Yeah, you can close this and you can create a new source file like for the existing demo project.
Okay. Do I just close it, or is there a different way to
You can
fix
close
it?
it. The rightmost corner is there.
Okay.
Yeah, okay.
Yeah, Aruna, over?
Yes, ma'am. Yes, ma'am. Over, ma'am.
Okay. Any doubts are there? Still, people can get the clarification regarding how to compile and create the project, compile and simulate. Okay, if everything is clear, maybe we, yeah. Any doubts
Ma'am,
are there?
in lab report submission, code should be handwritten or a screenshot of the software.
Better if it is handwritten.
Okay, ma'am. And output is screenshots.
Just output only, you take the printout. That's all. Printout or screenshots. Like if it is like saving the output file and attaching that, it's okay.
Screenshot is also no problem.
No problem.
Ma'am, do we need to submit all those first three combinedly or separately?
Separate, no? Separate experiments. Separate. It will be each title will be separate.
Okay.
And okay, every one of you, when you're writing the code, creating your project, it should be with your name or roll number. Okay. You're creating the file now. Your project title should be like along with extension of your roll number and name. So that in your output file, we'll be seeing that. Okay. Varun, Dheeraj.
Ma'am, you mean for writing project name in the software?
Yeah. When you're writing the code, when you're entering the code, creating the project you have now, there along with your name or roll number, you need to create the project.
Yes, ma'am.
For every project, so that it's authenticating that you are doing the work. Okay.
Yes, ma'am.
So every report should be handwritten. Handwritten, only output file will be the simulated window. Same as how you are writing the exam. Generate, take the PDF submission you have to give. Is this okay? If any clarification is needed, you can ask, or else we'll close this session and you continue working on your experiments now.